Right, so in this video we'll look at some examples. Basically we're going to start with simple examples and move on to advanced examples. So we'll look at couple of examples in this video, both simple and advanced, and we will go through many other problems during the session, right, online session. Okay, and now we can see the problem on this on the screen. So please note it down. Please note down the problem. So I'm not going to note down the problem on the board, and I'm just going to take down the data, necessary data, and do the question. So please pause the video and note down the question. Right. So this is the first problem. So these data are given: mass, radius of the circular path, omega is the angular velocity. And they are asking us to find the acceleration. Usually acceleration means centripetal acceleration and the centripetal force. So sometimes in this question you will see that centrifugal force and centripetal force. So these two are equal in magnitude but opposite in direction, right? Centrifugal force and centripetal force are equal in magnitudes but they are opposite in directions. Okay. So you can draw a diagram for this. So start doing it from now onwards, because then you will get used to it. Right. So centripetal force Fc. So it will be they don't talk about the method of application. Maybe it's a string, maybe it's friction force. We don't care. So they are saying that the particle is moving in a circular path with angular velocity 5 radians per second, right? So what is AC? Now you know that we have two equations for centripetal acceleration, that is r omega squared or v squared over r. Now v is not given, omega is given, so I'm going to use this one instead. R is 0.6, omega is 5, so this is 5 squared, so 0.6 into 25. So the answer is 15 meters per second. So I'm taking quick examples from Dance Pereira's book. So I have to give credits to him. Next, the centrifugal force. They are asking for centrifugal force. That actually is, it should be centripetal force. So Fc is we put F equal ma, we put F equal ma towards the center, right? Then we have to, now I'm going to use this format instead, right? So we should look for all the components forces towards the centripetal force. To represent that, I'm going to use this formula, sigma F, right? Sigma F m. Since I use r omega squared, I can use that one, r omega squared. So we have already calculated AC here, so we don't need to do this again. So in this case, this should be Fc, centripetal force, equal to m is 2 into 15 meters per second. That gives us 30 Newton. Right. It's very simple. Let's look at another one. Right. So the problem should appear, the second problem should appear here on the screen at the moment. Please note it down and try it yourself. Right. So these are the data given. Radius. Now a particle is moving in a circular path. They say radius is 1.2 meters, right? With a velocity 6 meters per second. So velocity means usually they are referring to linear velocity. They are asking us to find the acceleration, centripetal acceleration. So මෙතනදී රූපයක් අඳින්න ඕනේ නැහැ. මේවා physics problems වගේ දේවල්. So AC are of two kinds. I'm going to use v squared over r in this case. So that is 6 squared over 1.2. 36 divided by 1.2, and that is 30 meters per second. Right. It's very simple. Okay. So this is the acceleration of the particle. Now let's look at the third example. The problem will appear on the screen now. So note it down and try this by yourself first. Right, so in this problem, this particle is attached to a string, right? The other end of the string is attached to a fixed point on a horizontal table, and it is moving with a linear velocity 2 meters per second in a circular path. And the radius of the length of the string is 0.5 meters, which would be the radius of the circle, and m in this case is mass is 0.8 kilogram. They are asking us to find the tension, right? Now you have seen the type of forces that acts towards the centripetal forces. It will be tension, reaction, and friction. So let's start from here. So N is something that you have marked on the diagram. So you have to find what N also is, right? So if you put F equal ma in this direction, F equal ma, right? So all the force component, right? Sum of all the force component will be equal to mass is 0.8. And A would be, since V is given, it should be V squared over R, right? V squared over R. This is the equation that we are going to use. So let's put M. We have only T, nothing else. M is 0.8, V is 2 squared over 0.5. So the tension in this case would be 6.4 Newton. Right. So how do you get N? To get N, you put F equal ma upward direction. So we have N minus mg, mmg equal m0, because the particle does not have any acceleration in the vertical direction. So acceleration is 0. Which means N is equal to mg. So m is 0.8, g is g. So if g is 10, it should be 8 newtons. Right. So this is how you do this question. Very easy. Right. So let's do the fifth example. The problem will appear on the screen now. Pause the video here. Write down the question and start working out. So I will put the problem on the board, put the solution on the board right now. Now in this problem, it is about a particle attached to an elastic string. So very important, elastic string, which means its length is it's not specified actually, right? So if the particle is moving with a higher velocity, the string will stretch out to provide the necessary centripetal force, right? So length of the string is undetermined. Length of the string can be determined based on the conditions it is in at the moment, right? So when you attempt a problem like this where the string is elastic, you don't mention the natural length of the string, because string would definitely be stretched out, right? It would definitely be stretched out when it is moving in a circular path, or if it is in a conical pendulum, the string would definitely be stretched out even if it is not moving, right? If it is standing still, the string would still be stretched out because it's an elastic string, not inelastic. So you mention the length of the string, right? The stretched out string. Now the natural length. Natural length is L. Natural length of the string is L, and the modulus lambda is modulus of velocity is 3 mg. Natural length is L, right? So now this is moving in a circular path, so the radius they say is twice of L. So you can see that it is twice big as the natural length. Right. So in this problem, they are not asking us to find the tension, because tension can be definitely determined using Hooke's law. So you know Hooke's law. Remember, Hooke's law. So tension is equal to elastic modulus time x divided by natural length. X is the extension, extended length, right? So tension in this case can be found. This is 3mg divided by L. Extension is the length of the string at the moment, which is 2L now, minus its natural length. So the answer is 3mg L over L, 3mg. This is our tension, right? So now we can, they are asking us to find the angular velocity omega. To find it, we put F equal ma, right, in this direction. So all force components A should be what? Since we are going for angular velocity, I'm going to use R omega square. This is the formula I'm going to use. So in this case, we have only tension T equal M, R is 2L, R is 2L omega square. Now tension we just found already 3mg, 3mg. So m goes off. In this case, m cancels out, and this implies our omega is 3g over 2L square root, or to the power of half. Right, so I think I made a small mistake here. It should be 2mg. Sorry, 2mg, 2m. The mass of the particle is 2m. Sorry about it. Yeah, should be 2m, 2m. So 4m, 4. Right. Okay, so that is the angular velocity of the particle, the moment. Right. Then n, to find n, F equal ma. Please keep doing this because you don't get easy problems like this, but you have to learn from the simplest problem. So n minus 2 mg equal m0, n is equal to mg, n is equal to 2 mg. It's very important. So මේ elastic problem, elastic string එක පාවිච්චි කරන problem එකක් තමයි අපි කරේ. Right, so let's look at the sixth question. Now this is not a simple problem, quite advanced. The problem will appear now on the screen. Write it down and try it yourself. Now this is about two particles, right? On the one particle is on a horizontal table, and that particle is attached to a string, right? One end of the string is attached to that particle P, and the other end of the string is attached to particle Q, and the particle Q is vertically hanging, right? So they are asking us to find at what revolutions per minute the particle P has to move in a circular path so that the particle Q stays still, right? It is not moving. The particle Q එක එහෙමම ඉන්න නම් particle Q එක tension එකකින් අල්ලන් ඉන්නේ. It is attached to a string. So a string gives off a tension. That tension, if the tension is equal to mg, the Q particle will stay there. So that is the idea. But Q particle move in කියන්නේ tension must be equal to the weight of the particle Q. එතනින් tension එක හොයාගන්න පුළුවන්. ඒ tension එකට corresponding omega හොයන්නයි තියෙන්නේ. Right. So they are asking us to find the revolution per minute. To find revolution per minute, this is how you break it down. To find revolution per minute, you need to find the angular velocity first, right? So if you know the angular velocity is given radians per second. So you need to know how many radians it has rotated per minute, right? For that you have to multiply by 60. So that will give you how many radians. That means the angle, right? Total angle it has rotated. And to find revolution means a revolution means when it has moved by 2 pi degrees. How many revolutions? How many 2 pi's are there? To find that you have to divide it by 2 pi. So finally 60 divided by 2 is 30, 30 omega over pi. If you need to find revolution per minute, you can find it by this formula. So in this formula 30 is known, pi is known, omega is not known. Now we go to find omega. To find omega, you need to find tension. You need to find tension. Okay, so let's do that. In this direction, F equal MA, right? So sigma F, all the components M, omega ganna R omega square, right? So we have tension equal M R omega square, right? R is the radius. Then tension එක. Tension එක දැන් ඊට පස්සේ මොකද්ද මේගොල්ලෝ කියන්නේ? This string is not fixed. The string is attached to another particle Q, and what tension value, what value of the tension will make the Q to be at rest, right? After Q particle, this is for particle P කියන particle එකට, for particle Q, for Q particle F equal MA, it should be rest. මෙයා rest එකේ ඉන්න ඕනේ. So should be tension T minus mg equal m0. That gives you T equal mg. This is the second equation. Right? So from 1 and 2 මේ දෙන්න equate කරාම mg equal mr omega squared, m goes off, omega is g over r වල square root එක. g over r වල square root එක. right? තර මේක පස්සේ ලියන්න, ඊට පස්සේ මේක ලියන්න. omega you found, sum right, 30 over pi g over r. It's g over r. So notice here I didn't find n here. Please try to find n as well. If they are not asking to find n in the problem, don't do it. But I'm asking you to find the normal reaction, because in the future problems you will have to use the components of reaction. So that's why you should get used to this. Okay. Let's look at the seventh problem example. The problem will appear on the screen now. This is about a conical pendulum. A simple problem. Take this down and try this. Now this is about a particle attached to an inelastic string. That means this elastic string will not be stretched out. Inelastic string, length of L, right? Mass is m, and it moves in a conical pendulum. It moves as a conical pendulum, and the particle moves in a circular path, horizontal circular path, right? So we need to find the centripetal force in this case. They are asking us to show that the depth of O from A, that means AO distance, is independent of the inelastic string length. ඒ කියන්නේ මේ length එක මොකක් වුණත් 10 meters වුණත් 5 meters වුණත් 1000 meters වුණත් මේ දීලා තියෙන criteria එකට with constant angular velocity, they say moves with constant velocity omega, right? දීලා තියෙන criteria එකට මෙයාගේ මේ distance එක හැම length එකටම මෙයා equal වෙන්න ඕනේ. මේක same length වෙන්න ඕනේ. AO. L එක වැඩක් නැහැ. කියන්නේ L increase වෙද්දි මෙන්න මෙහෙම යන්න ඕනේ. right? Particle L increase වෙද්දි. L short වෙද්දි මෙන්න මේ ගන්නට තියෙනවා. Which means you can have to mark an angle. මොකක් හරි angle එකක් mark කරන්න වෙනවා. right? Angle එකක් mark කරන්න ඕනේ. This is a general question. So AO is L cos theta. So බලමට අපිට පේන්නේ this depends on L, right? Depends on L. So ඒගොල්ලෝ පෙන්නන්න තියෙනවා OA does not depend on L. ඒතර L වලින් independent කියලා කියන්නේ මේ cos theta AO L වලින් independent වෙන විදිහට cos theta behave වෙනවා, right? So let's try to find a value for L cos theta and show that that is equal to a constant. තර මේ AO constant එකකට equal කියලා ආවොත් එහෙම අපිට වැඩේ හරි. Right. So theta, so this should also be theta. So if you resolve forces the vertical direction, F equal MA, we have T cos theta equal to T cos theta minus mg equal m0, right? So that gives us T cos theta equal mg, right? So they are not asking you to find the tension. Tension එක අහන්නේ නැහැ. ඉතින් අහන්න යන්න එපා. Right. Then centripetal force in this direction. ඔයගොල්ලෝ දන්නවා මේ radius should be then L sin theta. This should be L sin theta. The radius. F equal MA in this direction. So we take all the components of forces equal M. Acceleration is R omega squared. R omega squared. That will be our acceleration. So in this case, T sin theta is equal to M L sin theta omega squared. L sin theta omega squared. Sin theta cancels out. T would be equal to M L omega squared. Equation 1, equation 2. Right. So from 1 and 2, I can replace T by this one, M L omega squared cos theta mg. Then බලන්න හරි ලස්සනයි. මෙතන දෙන්නේ මොකද? M to M ගියා L cos theta. L cos theta is equal to G over omega square. L cos theta is equal to G over omega square. So what is L cos theta? L cos theta is AO. L cos theta is AO. So this implies AO equal to G over omega square. But AO කියන එක ආවේ gravitational constant divided by omega square. तर මේ omega angular velocity එකම මෙයා rotate වෙනවා නම් AO කියන distance එක L වලින් independent. This implies AO is independent from L, or the length of the string. Right, so let's look at the other example. So the problem will appear on the screen now. Please note it down and have it. So this is about a glass marble of mass m is moving in a horizontal circle round the inside surface of a smooth hemispherical ball of radius 2r. The center of the circle is at a depth r from the center of the ball. Find the reaction between the marble and ball and the angular speed of the marble. Right. So this is a smooth hemispherical ball. I suppose it looks like a smooth one, hemispherical. Don't worry about it. Right. Okay. Now this particle, marble, moves on the inner surface of this smooth spherical ball. So when it's moving on the inner surface, so there will be reaction, normal reaction acting on the marble, right? May are smooth now. So the note here is that if it is smooth hemispherical bowl, right, hemisphere would result in a normal reaction that goes through the center of the hemisphere. This normal reaction will go through the center of the hemisphere, right? So they say that this circular motion takes place at r depth below the center of the hemisphere. So මේ hemisphere එකේ radius එක 2r ලු r වලින් පල්ලෙහෙන් තමයි මේ circular motion එක වෙන්නේ, right? So we need an angle to this because we need the component of n to get the equation of circular motions, right? So we need to know what r is in this case, what is the this length here because that is a radius. तर ඒව හොයාගන්න පුළුවන් අපි geometry එක consider කරමු. So OAC triangle consider කරමු මම වෙන මදින්නම්. Right? So this length would be 2r again. This length would be 2r. This is 2r. This is r. Right? So what should be this angle here? This should be root 3r. So this is a 90 rectangle triangle. Right. So this should be 60, right? This should be 60. This should be 30. Make a familiar එකක්. 2r sin 30. 2r sin 30 is r. 2r cos 30 is root 3 by 2. හරිද? तर මේක familiar triangle එකක්. 2r r තියෙන හින්දා මම කෙලින්ම ගත්තා. Right. So this angle theta here, theta would be 30 degrees. ප්‍රශ්නයක් නැහැ. දැන් we have to resolve vertically f equal ma to find the reaction because the reaction, normal reaction, the component of normal reaction will be acting as centripetal force. So that would be n sin 30 minus mg equal m times 0. So n divided by 2 is mg, n equal 2mg, n equal 2mg. Right. So you found n. Now f equal ma in this direction, right? So all the component of forces equal m. We need to find the angular velocity. So I'm going to use, I'm not going to use r here. So let's call it L omega square. L omega square. So we have only n cos theta. N cos 30 equal m. L, what is L? L කියලා මෙතන මම හෙව්වා root 3r omega square. Right? N is 2mg now. 2mg cos 30 is root 3 by 2 m root 3r omega squared. So that would give us omega is m here 2 here root 3 here g over r square. Right. So this is the angular velocity such that the marble moves in a circular motion on the inside surface of the smooth hemispherical sphere, which is at a depth r from the center of the hemispherical sphere. Right? This is in the circular motion. Right. So in the next video, you will look at banked a particle on a banked circular motion. Please go through that as well. ඒක ලියාගන්න එක මොඩල් එකක් තියෙන්නේ. ගණන් හදන්න ඔයගලන්ට ගොඩක් හොඳයි ඒ වගේ ගණන් ටිකක් මේ ටික අපි සාමාන්‍ය simple examples ටිකක් කරමු. Thank you for watching.